G'day chemists. So, today we're going to talk about the properties of elements, in particular the physical properties of them, and that'll lead us into our next lesson about the structure of the atom and the properties of that. So, let's start off with a bit of a summary about elements. They are all composed of one single type of atom, okay? That if it's not an element. They may join together to form molecules. You can have diatomic molecules, which is two, so it's oxygen, triatomic or polyatomic, but generally diatomic, triatomic, so oxygen gas, or ozone, which is O3, so that's triatomic. They cannot be physically separated or decomposed. You know, that's as small as they get. Unreactive elements may exist as free elements in nature. Okay, that's straightforward. If it's not going to react with anything, it'll just exist on its own. And gold and platinum are examples of that. Reactive elements, though, we rarely find them. Okay, so sodium is super reactive, and that's why it causes explosions when mixed with water. But it's not very so it reacts in nature, and we get it as sodium chloride or rock salt. All right. So let's have a look at the properties of elements that we are concerned with. If there's not enough information on here, feel free to look them further up. Look them up a bit more. So first we have melting point. These all tend to exist these are all what we're concerned with at 1 atmosphere. So that's sea level, which is 100 kilopascals. That's the pressure, the air pressure. So melting point, these are all specific to each element and each compound for that matter. Every single pure substance has specific ones of these properties that are just theirs. So melting point at 100 kilopascals, boiling point at 100 kilopascals. If we have a pure substance, we can use these to work out what they are. The density, so this is the mass per unit of volume, which at 25 degrees Celsius, 100 kilopascals. Here we're talking about the mass divided by the volume, so it's grams per centimeters cubed, and that's the unit. 1 centimeter cubed equals 1 milliliter. Electrical conductivity, so it's the amount of current or quantity that is transmitted through a unit cube when the potential difference between that unit, that cube, so the voltage, is at 1 volt. So basically it's how much goes from one place to another when the power behind it is 1 volt. And we measure that in Siemens per meter. In fact, usually we measure in megasiemens per meter, that's a good unit. Now, thermal conductivity is the rate that heat energy, so that's heat N, that's for energy, is transmitted through 1 unit cube, again, at a temperature difference of 1 Kelvin or 1 degree Celsius, the same. So if you've got a difference of temperature, so one side of the cube is 1 degree hotter than the other, the amount of time it takes for that temperature difference to go from there to there, so that extra degree to move it. And the unit there is joules per second per meter per degree Kelvin, or per Kelvin. It's not degrees Kelvin, it's just Kelvin. So joules per second per meter per Kelvin. Okay. Now, let's look to see how these properties tend to play out in nature. Along here, this is metals, semi-metals, non-metals. So the appearance, metals tend to be lustrous. Semi-metals have a low sheen, usually, and non-metals are dull. And that's because non-metal, like Jack Johnson, tends to be boring. Electrical conductivity, we have high in metals, and that's why they all play electrical guitars in metal music. Semi-metals is low, they tend to be semiconductors, whereas non-metals, no electric guitars, and that's because they're insulators. Thermal conductivity, again, is high for metals, but it's high, we had low for semi-metals for electrical conductivity, but It's high for semi-metals, so heat will travel right through them. Whereas non-metals, it's low. It's not nil, like heat will go through stuff. You'll still heat it up, but it takes a lot more. Malleability or ductility. So malleability is the ability to press it into a different shape. Ductility is to be drawn into a wire. It's high for metals, moderate for semi-metals, and low for non-metals. The density is usually pretty high for metals, not always though. Aluminium is very light, intermediate for semi-metals, and low for non-metals. Again, the boiling point, it correlates to the melting point as well, so you can consider them to be roughly the same, is generally high for metals. Some metals melt really low, boil really low. I mean, mercury starts out as a liquid at room temperature. Very high for semi-metals. They don't melt, like they do, but they're very, very hard to melt. And it's usually low for non-metals. And in fact, all gases are non-metals. Strength. Well, metals tend to be really strong, and that's why we use them for building stuff. Semi-metals, they're variable, they change. The individuals don't change, but there are differences between them. And non-metals are not very strong, and that's why anthrax and Pantera have been together for 30 years. And all your non-metal bands, they tend to not last very long. Okay, so those are the properties of elements, and yeah, see you in class.